Okay, thanks. Thank you, everybody. Pleasure to be here again at the Water Summit. IBM are proud sponsors again this year. Proud sponsors. This is a terrific event, really a preeminent, water gathering for Canadians. I do want to preface by saying that I prepared my presentation before the floods last week, and I do make mention to flood management in here. Just hope I'm not being perceived as opportunistic or inappropriate, but of course, flood management is part of water management, so don't be surprised to see some reference to that here. So without further ado then, I'm based in Montreal. I grew up in the East Coast, but I was born here in Alberta, and I'm delighted to be back here in Calgary despite the circumstances, but very impressed by the response that we've seen and the real Albertan spirit. And it speaks well to the theme for this year's summit, collaboration for prosperity, and we get to talk about the balance here. So why do we talk about collaboration and innovation so much? Why is this in fashion lately? I mean, this is really the essence of human spirit, and in fact is behind most of humankind's most remarkable inventions and breakthroughs. So why are we talking about it like it's a new thing? Well, in fact, we've come to realize that the world is much more complex and much more fragile than ever before. And as people have grown in number and consumptive behavior and resource intensity, we realize that there are a number of fragilities. There's certain global realities coupled with anthropogenic impacts and behaviors which have precipitated multiple interdependent global sustainability challenges. How do we sustain our current style of life without jeopardizing the future? Or perhaps we should frame sustainability as how do we sustain the planet so that there is a prosperous and reasonable future, or prosperous and secure future. Regardless, we're facing massive problems, and instinctively we seek help. We seek to collaborate when we're facing problems that are unprecedented and extremely urgent. And water, our most precious resource, is really at the heart of that, along with food and energy. It forms the foundation of a healthy society and a prosperous future. We've seen what too much water can do. It's a bitter irony that we're here at a water summit this week on the heels of a huge flood which devastated parts of southern Alberta. Elsewhere, there's talk about dire drought, again, in other parts of the world that produce a lot of food. Our water infrastructure is creaking and crumbling beneath our feet, and there's threats of contamination and toxification and eutrophication threatening our water systems as industrial activity increases and population grows. Our ecosystem services are probably misused and exploited and poorly understood and certainly undervalued from a sustainable return on investment perspective. So as our demand for natural resources, especially water, exceeds a secure supply, we're threatening a prosperous future. So we have to find a balance for how to use water efficiently to power a reasonable economy, a strong and prosperous society, a high-performing environment, and a healthy society. And so I'll talk a little bit about how we're trying to contribute to that here in IBM. So this is the backdrop then for what got us started on this. And of course, fear and risk are great motivators for collaboration and innovation. And these trends here are bigger than any one organization can address on their own. So obviously, we're drawn to turn to help. And these trends, along with IBM's vision of a data-soaked future, was really the impetus of the Smarter Planet program. And it took courage and will for us to explore these formidable trends, but we drew up on our core competency of data management and our exposure in two of these areas in particular, energy and water, to try and reduce our risk. And so we instrumented some of our fabrication facilities where we use ultra-pure water to produce microchips so that we could capture 40,000 data points per second, so that we could optimize how much water we were pulling out of the river and how much chemical was needed to treat a certain amount of water depending on the production run of microchips. And then we were pulling heat from the processed water and pumping that back into the HVAC system of the building in a closed loop, sustainable kind of fashion. And that worked really well, like double-digit improvements in water and energy footprint. So much so that it actually drove the development of a new division of ours known as Business Analytics and Optimization, which is the technology which powers our Smarter Planet portfolio. And of course, the other key input for that is big data. Not just water systems and food systems and energy, but transportation and buildings and healthcare and waste optimization. All of these critical societal support services use increasing amounts of data. And we hear from people today and all over that, we've got too much data, in fact. But what we found was that if you can model your data and structure it properly, then the more data streams that you can ingest, the more insights you can pull out of that. And so when Dr. Taylor says, ask IBM what they're doing here with water, of course, we're not water engineers per se, we're information engineers. And we can optimize use of natural resources and build in more efficiency and resiliency and design into water systems by drawing on principles of big data and analytics. And I try to simplify this here. In the backdrop is actually internet traffic around the world, and we model this kind of stuff all the time to reveal patterns and insights. And analytics incorporates data visualization and next generation kind of information management techniques. But at the heart of this, I just want to boil it down. It's kind of like you've got two data points. Imagine you have a really high resolution telescope. Before that, you're looking into space and you see just a white blob, a white bright light. And when you've got higher resolution, you actually realize that's 15 different stars, right? And so that's the essence of big data. You've got a ton of data already, but what do you want to look at? And when you do have higher resolution on your data, you can filter out the stuff that doesn't matter, and you can find real gems, real value in the data that you have. And so I'm trying to explain that in basic terms to you guys here of how we use those principles and techniques to improve functioning of water systems. And I'm in the Smarter Water program, but there's other aspects of Smarter Planet. But for purposes of my job, I tend to think of industrial, municipal, and then watershed. And so I'll talk a little bit about how our technologies and big data principles kind of apply to those three different domains. So let's continue in the abstract for a minute. Let's consider my infant son, who up until recently didn't really have a good idea of his left hand from his right hand, right hand, didn't know what they were doing, and he still has trouble getting either hand up to his mouth properly. And it's because of his central nervous system and peripheral nervous system working in concert, and those connections and these feedback loops in a complex system, that he's able to avoid hot things and sharp things and become a learning instrument and to improve his coordinating his new limbs, right? So systems, complex systems, we're kind of at a new era. We were very good. Imagine, the left leg and the right hand and the eye and the mouth of a small child. They work perfectly well, but they don't really coordinate well together. And so with the increase in population and the overlap of industry and society and natural systems, then we have all these overlap of systems. So now the world has become one big super system, but we're really not very coordinated. And so it would be really good if the left hand did know what the right hand was doing. And so we see that in the context of integrated resource management. And so this is not a novel concept, but here in Alberta, we're starting to see domains of wisdom and expertise, like the people in this room here, and levels of government and industry and NGO and conservation agencies and whatnot are starting to develop a water nervous system. And we're using this kind of complex systems design along with big data capabilities and technology to harness the knowledge and the wisdom of water experts so that they're operating in a more self-modulating and continuous learning kind of mode so that you don't have an uncoordinated approach to managing this very precious resource of ours. So there's two examples I want to just quickly take you through here. Digital Delta, this is the one that I mentioned. I prepared this 2 weeks ago. This was a long-running partnership that IBM Netherlands had with Rijkswaterstaat, which is the Dutch Ministry of Water, along with Deltares, the Science Institute, and the University of Delft, and a number of other collaborators. And this has been a long time in the running, but last year there was kind of a formal agreement that was signed where we will be providing a technology platform to help those different agencies and institutes combine their wisdom and their knowledge and their big data to help with flood management policy and strategy, drought mitigation and overall management of the water network in the entire country of the Netherlands. This is really pioneering work. Obviously, the Dutch are known for their water expertise. 55% of the Dutch population live in areas that are prone to flooding. So they're obviously motivated and have been for centuries. And we're quite proud to be working with them and helping to bring together all the expertise that's out there. My Dutch colleagues told me that even though they know a lot about water, the challenge is really governance and collaboration. If you look at the Netherlands, he said, if you zoom in on any one particular sector or domain within water, he said, and you took a microscope to it, there's actually multiple projects going on in each domain where you've got a redundancy of effort and a lot of redundancy of data being produced, and it's not coordinated. Even among a very pragmatic, very motivated society, it's difficult to do that. And what that translates to is an enormous amount of cost. So in the analysis that's been done leading up to the signing of this project last week, and this is years in the works, they've looked back at the data that they've collected, and they've determined that the traditional water engineering projects in the Netherlands, 30 to 40% of the labor effort goes into managing the data. So storing it, sifting through it, validating it, cross-referencing it, eliminating redundancy, and then acting on the really good stuff and putting a seal on it and saying, okay, let's go. And that's an enormous figure, 30 to 40% of any project, but you're talking multiple projects across an entire country. Another interesting, smaller scale example he gave me of the innovation that's coming out of this is they have a series of levees, of course, in the Netherlands, and they use historical information to tag when a levee has to go into maintenance mode, and that incurs an enormous cost. And so typically they look at historical records and they say, okay, this levee's up for maintenance, and it's tens of millions of dollars per kilometer of levee. These are massive structures and a lot of due diligence to maintain them. So there was a small company that was using high-resolution satellite imagery to examine these levees, and they were able to determine through various imaging techniques down to 100-meter sections of what part of a particular levee might need attention. So if you could focus in on 100 meters instead of a kilometer, you're talking about massive savings. And this company was having a hard time getting noticed. They were just one of many niche players. And I always like to refer back to natural systems and whatnot, where you have, small niche players play a critical role in the ecosystem. And so this niche player was able to get attention and traction and able to commercialize and demonstrate innovation because they have this integration platform we have this integration platform as part of this Digital Delta program. So again, we're not we're not engineers in a traditional sense. We're integrators. We're really good at bringing together different systems and different data so that people don't have to get bogged down in that kind of spreadsheet to spreadsheet kind of task, and there's more labor freed up for higher value, innovative type of activities. So we're quite proud of that one. I know the numbers here are a little bit small, but if you Google Digital Delta IBM, then you'll find all the details on this one. And I think it's quite pertinent to the situation here in Canada and Alberta specifically. This is my last example. I'm going to scratch Brian Margellis's back here because he talked about Southern Ontario Water Consortium, and I'm proud to mention this one again. I've been the project manager from IBM for the Southern Ontario Water Consortium for some time. And in addition to a fantastic group of people, this is a really pioneering work effort, really interesting collaborative model. We've got 9 universities. And in speaking with some of the research leads there, they were saying that because they've managed to bring together these different nodes that you see here, drinking water, wastewater, e-tox, watershed, each node is informing the other, is actually creating opportunities that they didn't know existed if they hadn't come together, to the point where they're actually creating new postdoc positions for students to explore new research areas, new innovations, new technologies that they literally couldn't see without coming together. So here we have this high resolution system integration benefit of big data and facilitating that. We literally call these things collaboration platforms. And so I think this is a landmark project. It's interesting, the folks from IBM Netherlands and IBM Israel are actually calling me wanting to know more about that. So I think that's an ultimate gesture of how important this project must be. We see work like this going on in Alberta here, and this is the kind of collaboration and innovation which really puts Canada on the map and ensures a blue, prosperous future. So I want to thank you very much for your time.